Hello, students. I would like to welcome you to my Intro to Geology review. I would like you to use this information to help you study this information for your tests and to know it for the future units we use for the rest of the geology. So I'm going to click here and I'm going to start the presentation. All right, here it is, Intro to Geology review. So if you remember back in the very first section, we learned about Mr. James Hutton here from Scotland. And if you guys remember the trip that I took in Scotland and the pictures I showed you, he is the father of geology. He's the one that started studying rock layers. And he came up with this theory of uniformitarianism, basically geologic changes that happen over a long period of time. Before James Hutton came around, they thought all geologic change was just catastrophism. But once they brought up uniformitarianism, as you guys remember, it was not an accepted theory. And as you guys know, scientists, they don't agree on everything. We don't agree on everything as it's part of our human nature. Maybe when you talk to your parents, you don't agree on everything. And the other theory is catastrophism. This was the most accepted one at the time. It's a geologic changes that happen suddenly. So some examples are volcanic eruptions, meteor strikes, hurricanes, you guys can think of them. Uniformitarianism, some main examples are erosion, mountains growing, rivers cutting through mountains. You guys, those are some of the examples. Well, after James Hutton passed away, Charles Lyell continued James Hutton's research. And just like in science, when a person's passed away, their research does not go away. Other scientists will pick it up over time. That's why we've advanced as a society. The biggest thing Charles Lyell did with the research was that since not all scientists agreed on everything, it took a lot of time for the ideas to be accepted. And over time, they have learned that geology is made up of geologic changes that happen over time and catastrophism. And in most cases, they go hand in hand. Here's some pictures for you. Right here, if you look to the left, this is a mountain. This is Mount Everest. And as you know, this took millions and millions of years for this to grow. This didn't happen overnight. And to the right here is a volcanic eruption. This is an example of catastrophism. Hope you guys are enjoying the show so far. All right, the second section was all about relative dating. If you remember, relative dating, it determines whether an object or an event is older or younger. The example I kept giving is, remember, I am older than you. If you took a brick iPhone back in 2007 and compared it now, you are going to look at it and basically tell, guess what? The older iPhone, you can tell which one's older, which one's younger. The thicker ones are older. And also in this section, we talked about superposition. Superposition states that younger rock layers lie above older rock layers. And this is assuming this is undisturbed, because we're going to talk about some disturbances in a couple minutes. All right. In the geologic column, I bolded the word ideal. Remember, this is a geologist's dream. It's a sequence of rock layers that contain all the known fossils and rock formations on Earth. Is there a place on Earth that has every single one in one place? I'll take a second and think about that. Hopefully you answered no, because guess what? There is no place on Earth that has all of these in one place because of all the different disturbances. All right. Now we go to rock disturbances. Remember, there are four types of disturbances. You have tilting, rock layers that tilt to one side. It's pretty self-explanatory. Folding is when the rock layers that bend. Think about how much force it takes to bend a rock layer and how much time it takes. Intrusions, igneous rock that squeezes between other rock layers. You ever have that person who butt into your conversation when you two have a conversation? They are committing an intrusion. And a fault. Remember, it's not my fault. I broke it. Or it is my fault because I broke it. Remember, it's a break in the crust. So these are the four main types of rock disturbances that happen all over the world. Here, I have some pictures of them. If you take a look at the tilting, if you look right here, you will notice that it is tilting. All these rock layers have tilted. And these are internal forces in the earth, which we're going to get into plate tectonics. Folding, literally when rock layers buckle and they bend. At one time, all of these rock layers were horizontal, undisturbed. Now take a look. They are bent. And the other two, intrusion. Remember that rude person who interrupted your conversation? You are intruding on my space when molten rock from the earth basically goes in and they interrupt or they break into other rock layers. And then here, if you look right here, it's a crack. This is a fault. This is a break in the Earth's crust. And later, when we get into plate tectonics and earthquakes, we will talk about the causes, what causes this, and the results of it in our everyday lives. All right. Third section was all about absolute dating. Now, this is the time when we did the Twizzler lab, and this gives us the exact age of a rock layer or a fossil. So how they determine this is, remember, parent isotope turns into a daughter isotope. So for a so at during a certain time, half-lives is the time that it takes for one half of a parent isotope to change to a daughter. So if you remember, carbon 14 is the isotope they use to date fossils. It takes 5,730 years for half of the material to turn into daughter. Remember, just like the Twizzler lab. Twizzler lab, you start off with 100% Twizzler. And every time I said half life, half of it turned into daughter. It does not completely go away. And also remember, too, when it is decaying, it is also it is gradually over the time. If you remember, uranium 238 has a half life of 4.5 billion years. So here's the example I gave at the bottom here. Parent starts off at 64%, daughter that doesn't exist yet. After one half life, 32 milligrams is parent, and the other 32 is daughter. Take a second and think about it. If we did a second half life, what amount would be parent? What amount would be daughter? All right. Hopefully, you were able to come up with 32 milligrams. Just kidding. 16 milligrams will be parent, and 48 milligrams will be daughter. That's after two half lives. Half life is simply the time that it takes. So every different isotope has a different half life. And the last section we've been working on, is most current in your mind, is fossils. Fossils, they tell us a lot. Okay, first of all, the main type of fossil. All right, one of the main types is amber. This tree sap that preserves the organisms. Remember, this is one of the only types of fossil that will preserve the entire organism. It's really cool. Fossils tell us a lot. Why do we study them? Why do we care? I live in Naperville, Aurora, Illinois. Why should I care about a fossil? This is stupid. Well, fossils can tell you how an organism changed over time. That's part of the evolution. It makes a segue with biology. Also, it's all about the climate of Earth during that time. I mean, like I said, I should say time. Typo. Oops. They also tell us how the continents move over the period of time. If you look at certain fossils, there are certain fossils where you may find in New York City, and also you'll find them in Scotland. That gives you evidence that one time Pangea was a real thing. Remember, humans only live 81 years. Fossils have been around for millions and millions of years. So how do we know that these events happen? This is all evidence to help us collect that. There's a certain type of fossil we don't know about. We don't know about soft-bodied organisms because simply they don't have bones. And if they don't have bones, they decompose way too fast. Without bones, you're just gone the life. Or over that time, once they die, they're eaten by predators. So over time, there's not a lot of soft body organism fossils because they really didn't stay around very long. Last type of fossil are index fossils. These are the most common types of fossils. These are trace fossils. These are found in rock layers, and they can give us a relative age of the rock layer. Okay, this really gives us that, okay, we notice that an ammonite is found in a rock layer, and the ammonite is 175 million years old. What is the approximate age of that rock layer? I'm going to give you a second to let you think about it. All right, I'm back. The age is, hopefully you said 175 million years, because that tells us that if that fossil is that age, The rock layer around that is around the same age. I have a couple picture of fossils here. Right here is a squid. It's a soft body. It doesn't have any bones. So chances are we're not going to find a lot of squid fossils because of the main reason. No bones, decompose too fast, and eaten by another organism. And right here, we have an ant or some type of bug that's caught in amber. So here is a type of fossil right here. Well, that is the end of my review. I hope I've been very helpful to you. I hope you are at least hope you are enjoying this unit. If you're not enjoying it, I hope you at least find an appreciation for why it's important that we study geology because they tell us about everything we need to know. Have a great day and good luck studying on your test.